Hi class, in this video we are going to talk about recognizing the requirements for a probability distribution. So let's talk about what those requirements are. A random variable x must be, first of all, numerical, not categorical. In other words, I can't have a probability distribution out of people's favorite colors. Okay? The sum of all probabilities must also be equal to 1. We talked about that in a previous video. So the sum, if you were to have your chart with your probability distribution, the sum of the probabilities must be equal to 1. And each probability value must be between 0 and 1 inclusive. What that inclusive means is that I can have an event with a probability of 0, and I can have an event with a probability of 1. That is totally okay. All right, so we are given two probability distributions. I'm going to call the first one A. That's the one on the left. And the second one on the right, I'm going to call that probability distribution B. And we are asked to use these requirements to determine whether these are probability distributions, and we are simply answering yes or no. You're not really going to have to worry about the first, all right, requirement of being numerical. We're going to assume that your data here is numerical. All right, so really you're going to be checking the second two requirements, the sum of all the probabilities equal to 1, and that each probability value is between 0 and 1. Okay? So if we look at A, notice that again, much like the example from a previous video, my probability distribution has an X column and a P of X column. Okay? So what we are focusing on is the P of X column. So if I were to look at table A, and I look at each P of X column, I notice that the probability of X equals 2 is negative 0.096. Well, that is not between 0 and 1. All right, so that entry causes table A to fail as a probability distribution. So, no, table A is not a probability distribution, because P of 2 is a negative value, and we cannot have negative values. Okay? So as you can see, maybe that second requirement is the easiest to check for. You simply check each P of X in your probability distribution and see if it's between 0 and 1. Really, mostly what you're looking for are values that are bigger than 1 or negative. All right, so let's look at table B. So table B, if you were to pause your video and go look at each of those probability values, you would see that each of them do satisfy that second requirement. Each one is between 0 and 1, so we're good on the second requirement. So let's move on to that other requirement, the sum of all probabilities equal to 1. So what I'm going to do is I'm going to sum up all the values in my P of X column, and I'm just going to plug each of those in my calculator. I'm not going to read them out. Again, pause the video if you need to go read your table. And when I do that, my calculator gives me 0.998. Well, that's not exactly 1. The sum of my probabilities have to equal exactly 1 to be a probability distribution. All right? And 0.998 does not equal to 1 as much as you might like to round. So this is not a probability distribution. Table B is not a probability distribution either. Let's move on to the next example. Class, let's do the next example. So here in this example, we are going to use a probability distribution in order to answer some basic probability problems. So we have to the right, a probability distribution for the sum of two dice. This is the distribution that we created a couple of videos ago. So in this case, we can trust that this is indeed a probability distribution because the problem tells me so. It is a probability distribution, which means I'm not going to have to spend the time to check against those requirements from the last example. Sometimes you may have to check. In this case, we're told that it is indeed a probability distribution, so we're going to trust that it is. All right, now I'm going to answer a few questions. The first is to find the probability of tossing two dice and seeing a sum of exactly 8. So I'm going to look at the wording exactly 8. And I want to think about what that really means as far as an equality or inequality goes. When I see the word exactly, that means I'm looking for one value. And I want x to be exactly 8, so I want x to equal 8. So that's going to be equality. So I'm looking for the probability that x equals 8. And that's how I'm going to write it. I'm going to write it P of x equal to 8. So this means, again, that I'm going to look for one probability value in my probability distribution chart. And since I'm looking for P of x equal to 8, 8 is what I'm going to find in my P of x, in my probability distribution table. So I look for 8, which is going to be under the x column. And my answer is going to be the P of x associated with 8. So P of x is 5/36 for 8. So the probability of getting a sum of exactly 8 is 5/36. Number 2 says I want to find the probability of tossing 2 dice and seeing a sum of 4 or less. So again, I'm going to look at that wording, 4 or less, and I want to talk about what exactly that means. So the first thing, am I including 4? Yes. 4 or less means I want 4 and any values that are less than 4. So what this relates to is less than or equal to. So what I'm finding is the probability that x is less than or equal to 4, and that's how I'm going to write it. P of x less than or equal to 4. And to find that, I'm going to look for 4 in my probability table, and I'm going to look for values less than 4. So in that case, that's an x value of 3 and 2. So I'm looking for the probabilities of 4, 3, and 2. And then to find the probability that x is less than or equal to 4, I'm going to add up P of 4, P of 3, and P of 2. All right, so I look to the P of x row, or column rather, I look to the P of x column for each of those, and I see P of 4 is 3/36. P of 3 is 2/36. And P of 2 is 1/36. And again, I'm just going to add those up. Since I didn't simplify my fractions, I can just add the numerators. My denominator will remain 36. And I get an answer of 6/36. Now your homework is going to want a simplified fraction. So let's go ahead and simplify by 6. So I'm going to divide the numerator and denominator by 6, and I get 1/6. So the probability of seeing 4 or less, or rather P of x less than or equal to 4, is 1/6. And then finally, number 3, I want to find the probability of tossing 2 dice and seeing a sum of 11 or more. So I'm going to look at that 11 or more, and the first thing I want to ask is, am I including 11? Well, it does say yes. 11 or more means yes, I'm including 11, and then anything more than 11. Well, that more means greater than. So more and greater than are the same thing. And since I am including 11, this is going to relate to greater than or equal to. So really what I'm finding is P of x greater than or equal to 11. Okay? So now that I know what I'm looking for, I need to come over to my table. So I'm going to find 11 and any x value that's greater than 11. Well, in this case, there's only 2. There's 11 and 12. Okay? And again, just like I did for part 2, I'm going to look at the probability value for 11 and the probability value for 12, and I'm going to add them up to find P of x greater than or equal to 11. So P of 11 is 2/36, plus P of 12, which is 1/36. I add those up to get 3/36, and I'm going to simplify that to 1/12.